Good evening, guys.
Today we are going to discuss about the assessment 3, which is focused on develop and deploy smart applications in the cloud. We are going to develop a web application for a business case scenario for smart systems private limited. It is an IoT based smart application development company, so we are going to develop a cloud based web application that is going to display the smart home temperature um, generated by Python API using IoT Core Amazon.
Some services provided by Amazon Web Cloud Server. So now I'm going to show our output. I mean, the final output as we made as a group assessment. So this is our final output file. So it's a smart home temperature IoT API based application. So we have already tried some examples inserting from our Python API base. So these outputs are already shown here. So now I'm going to demonstrate how we are going to deploy this like these applications through our Amazon Web Server with the support of EC2 and the IoT core. So I'm going to click on the EC2. Already we have created some instances. So in the left side panel under the instances menu, so I'm going to click the instances. So I have already created some instances. So for this assessment, I created the smart systems web server IoT. So these instances assigned with this our final output of this our web interface. So I'm going to select this instance and I'm going to connect my instance. So already it shows our zone and the IP address and everything. So I'm going to click this, connect this instance before we are able to see the public IP version for address, which contains output of our website. So we are able to see here. So this is our public IP address. So I'm going to connect my instance. Yep. We use the MySQL DB and I'm going to show uh, the files which connected with this our Node.js. So I'm going to select the list command. So we have already created some API server JavaScript files and view the API. I mean this API server JavaScript file. This is our list of applications. So now we are going to uh, connect our IoT based core application with this EC2. So first of all, we need to go to the AWS IoT core. So I'm going to search IoT core. So I'm going to click the connected device. So these are the steps we need to follow to connect our EC2 server with the AWS IoT. So it's already uh,
This is called Amazon Web Cloud Server Endpoint.
and now I'm going to show you with creating another new device with IoT. So I'm going to click next. So I'm going to assign a new name. So IoT 02. So if we want, we can select the thing type and other settings. If we need, we can modify as per our wish. But I'm going to skip these other steps. So I'm going to select the next. So I'm going to select the platform as Windows 10 and IoT device SDK as Python. So we are going to use the Python API. So we need to install the Python in our lab. So we already installed the Python on our laptop. So I'm going to select the Python and click next. So we need to download the download connection kit. I'm going to download the connection kit. After it, we need to extract the connection key. So I'm going to move this file into my personal drive. So I'm going to move to the D drive and make uh, another folder demo. So I'm going to move the connect device package into it, the demo folder. I'm going to extract. So we can see the certifications file, private key and public key, and the other important files are appearing here. So next step, we are going to select next. So our interface are ready to deploy. So now I'm going to run the PowerShell as an administrator mode. So I'm selecting the PowerShell, run as administrator. I'm going to set the execution policy, otherwise it won't run. So I'm going to select the copy. I'm going to run in the I'm going to run the set execution policy in administration mode. So I'm going to select, and I need to install all other important aspects. So I'm going to select A. So based on these commands, we need to select just to all. So I'm going to select A. So I'm going to show the my path of where our the folders is appearing. So I'm going to select the folder path and selecting, and then after I'm going to start. So slash start, it's already mentioned by step. So I'm going to select this command. I'm going to paste here. So this downloading AWS IoT root certificates from our AWS web server to my local drive. So we can see there is a folder is appearing now. Yeah. So now my IoT cloud is going to display the message. See, it's appearing from my PowerShell terminal to my AWS IoT cloud server. So we need to finish other rest of the steps. So I'm going to select the continue. So we need to view the things what's going on between our AWS IoT cloud server and our terminal. So I'm going to click the view all things, and we need to do some settings. So I'm gonna select the created IoT 02. So IoT 02 is my things name. So I'm going to select this one. So we are able to see the certificates is already appeared here, and policies and everything. So I'm going to select my certificate. See, under the certificate of this ID, we are able to see the policies and things. So I'm going to select the policy. So IoT 02 is my thing name. So I'm going to select the IoT 02, the policy. So I'm just selecting. So there are some policies already published, and we need some policies. If we want, we can select and delete, or we can modify as per our requirements or the user requirements. So I'm going to make some changes via edit active version. So I'm just selecting this one. So policy version status, active policy, set the edited version, active version for this policy. So I'm going to select, then only if we do some changes on our Python file, then only it will appear on our AWS IoT. So that's why we need to enable this active policy setting uh, in this dashboard. So I'm going to serve as new version. Yeah, our policies has been successfully updated. Now I'm going to MySQL test client, and then after now I'm going to stop this PowerShell. So it's already appeared here. So I'm going to stop my PowerShell. So it's already stopped. So likewise, we are going to uh, use our temperature for output from the Python API. So this demonstration is going to lead by Jack. Jack, you can lead up. Thank you.
All right. So
And just
can I
stopping
share?
my screen share, you can able to share your screen.
Yeah. So before passing to Armin for demonstrating the message routing, so I'm going to cover what we are going to do after we have registered the IoT devices. So once we create the IoT thing, so we need to go to the IAM to create a role for it. So before we create the role, we also have to replace the Python code to the packet, which Jenica already showed, in order to simulate the temperature readings. So after we replace the Python code, we go to this IAM dashboard, which is the identity and access management. And then we go to the, we're going to create a new role. So here we create the roles here, create role. Okay, so we're choosing the AWS services and for this entity type and also for use cases, we are going to choose the IoT here. That's for creating IAM role for the IoT we just created, and then we just click next. Here we can review the policy, which is default here, and then we click next. After that, we can paste the policy here for allowing the access to the specific service here. So here I will just keep it the same. And then after that, we can create a role for that IoT thing we just created. So we have already done that. I can show you here. For this one, IoT service is the IAM role we created for that thing. Yeah, I show the different policy here. For example, we can take this one as an example. See if we can see the policy here. Maybe not. Yeah, here. So it's basically allowing the IoT service, our IoT devices to call the AWS service. So that's pretty much for the step one. We are going, we config the IAM role also to set up IoT core things. So moving on to step two, how to route the message, I'm going to pass to Amen. Thank you.
Thanks, Jack. So first we'll need to create a routing message rule. Jack will take care of this.
Yeah, let me just cover it as well. So for creating the message routing rule, we go to the IoT core here. And here we can find the message routing and the rules here. We just create it. Here we click create rule. So in order to route the MQTT message to the AWS service, we simply just create a rule for that. So we can just rename it as what we like. And then you just click next. So here we using the SQL query, basically we just extracting all what we have from the Python which we generate for the temperature results. And then we click next. For the action one here, we are going to choose the publish IoT. We publish to IoT topic. Let me see this one. And then for the, here we choose one for the quality service. So we make sure the message is delivered at least once. and then we choose the relevant topic here. So when we subscribe it, we can see the message. So for the IAM role, we select the role we just created earlier. So which is this one, IoT service. Then we click next. So here we can review everything, and then we can create a rule here. So we have already created a rule, which is this one here. So moving on, I will pass to Armin to cover the message routing. Thank you.
Okay, now Jack will take care of the screen sharing. I'll do a presentation for this part. For now, we'll create an S3 bucket, which will store our data. So once we click that create bucket button, we have to use something unique for this name as it can't be a duplicate of it. Under object ownership, we choose ACL enabled. So the other AWS accounts can manage the objects. Once we create that bucket, we update the policy.
Yeah. So let me move to the
Yeah, all good. We've already created one. So now for the policy of it, we allow S3 to get object and put object for that appropriate IAM rule. Yeah. That should be good.
Yep.
Now we'll route the messages to S3. We'll have to create another rule. We already have one which says save to S3. And for that, the SQL statement. Can we just view the one that we already have?
We will show it later, but because this video is more like to demonstrate how to set up it.
So we'll name the rule save to S3. We'll go to the SQL statement next, which will be select star from sensor. Yep. And for action one, we'll choose store messages in an S3 bucket. That's the one. We'll put the correct details in here. The IAM role that we created before.
Yeah. And then next.
And we can save that rule.
Let me see.
Going to select here.
Now that is done, the messages sent to that topic will also be saved to S3. Yeah, we already have one, so yeah. Now the last part for this is routing messages to CloudWatch. We'll now configure logs so we can monitor messages and errors in CloudWatch. So again, we'll create another rule calling it save to CloudWatch. The SQL will be the same because we want all the data that we get. Select star from sensor. For action one, this time it'll be send message to CloudWatch logs. That's it. We'll choose the group and the IAM role. And once this is done, once we click next, this should be getting us all the logs whenever the data is passed through.
Yeah. Before we click next, there is the
We need
error
to
part
enable the
here.
Okay, sorry. Yeah. For the error action, we have made a separate, which is optional, but we have chosen to go for it. This time we'll log to a different group, like IoT error messages.
Yeah.
And same IAM role. And now we can activate this rule. Now we can run our updated Python script again. after everything is set up here.
Yeah, let me show the car wash now.
Yeah, I'll let Jack do this part of it. Thanks, Jack. Yeah, so we'll need everything just to check if it's working. We'll need the CloudWatch logs. We'll need the S3 bucket. We have it there.
Yeah,
So yeah,
so
the
it's
logs
showing here.
are working.
Yeah,
And for S3,
yeah, I can show it.
I think guys, 10 more minutes for meeting. If the meeting end, I will start again.
Yeah, sure.
we good. Okay, and yeah, we have a JSON object in this. So we're getting data in S3 as well. We're getting logs in CloudWatch. It's working how it's supposed to. And messages are being published to the topics.
All right.
Are we done?
Yeah.
Okay,
So,
thanks everyone. This was our presentation. We didn't introduce ourselves, right?
So moving on, I will be covering the backend logic for processing and fishing data. So basically, the first thing we're going to do is set up a DB. So here we can search from the AWS website, DB here. So which I already enter into it. Here we can create a table. So we put a name here for the table. For the partition key, which will be used later on in the Lambda function, we put the unique, a partition key for the table, which we use a device ID here. The type of it will be string. Also a short key, we use timestamp, which is the number. So here we keep it as a default setting, then we click the create table. So we have already done, so we can show here. So this is a table we have created with the partition key and also the short key we mentioned. After that, we're going to create two Lambda function. So basically, we have to create one Lambda function to write the data to the DynamoDB we just created. And we have to create another function to read the data whenever the HTML sending the request to the API gateway, we will trigger the second function. Then we will fetch the data from the DynamoDB. So for the first function, we click here to create a function. So we put the name route to DynamoDB. The runtime we are using will be Python. So if other thing we will keep the same. Then we just click create function here. So after we click this, we can show. Let me just maybe I can just put a demo here. So after clicking this button, then it will automatically create a function which you can paste the Python code to for the trigger. All right. For the second one, it will be the same, just enter the name, whatever you like. So I'm going to show the first one, which we used to write to the DB. Just give it a second. Meanwhile, I can open another one as well. Yeah, here is the first function we used. So here we name the AWS service, the DynamoDB, also the table name we just created with, and then we use the partition key here and also the short key here. This is the result we are going to, we want to write into the DB. So these are the code that write the data into the DynamoDB table. So another function we're going to show is here. So we can see using the partition, using the specific ID here, and then we can retrieve the table from the DynamoDB, and then we can get the result, which will fish the data from the DB, then to the HTML, which we can show the temperature on our web application. Moving on, we need to create the rule for it. So I'm going to go to here. Let me search it. So we are going to IoT core. To create a rule, we are going to the message routing here. Then we select rule and click create rule. So here we, for the Lambda function, we name a rule for it. All right, and then we just, similar to what we did before, we select all from the table for the SQL statement. So here for the action one, we are going to use the Lambda function. So we select the surface, and then we select the function we're writing to the, we're reading for the data from the DynamoDB. So we use this second function we created before. All right, then we create next to create this row. So after we create these rules, which we already done here, I can show here. So this is already done. Moving on will be the setting up for the API gateway. So here, so we can search here API gateway here, which will direct to this page. We click this button to create an API. For the type of it, we are using the REST API because we can use the AWS service as well. Here we choose the new API, and the name for of it is anything we like maybe 0IT2260. And then we just click create API here. So after we click this button, then we can see there's resources on this page. So later on, we have to update the policy here so that it allow the API to get the to access to different services. So for allowing Lambda function to access to DynamoDB, we have to configure the IAM roles. So we go to the IAM roles. So here we create the role. Here, again, we're using the AWS service. For the use case, we choose Lambda here. Click next. So these are the default policy. We can just click next. So here we are going to edit the policy, which we already done. So here I can show you. If we go to the IAM pages here. So this one will be the one. So we're going to edit the policy to allow the Lambda function to access to the DynamoDB. let's see, yeah, here. So we copy this. Actually, we edit using this one when we create policy here. So after we configure the IAM roles, that will be all for the setting up for the API gateway. So moving on to the last part, for deploying the web application, I will pass to Jeniken to talk about how we using the EC2 to run the web application. Thank you.
Thank you, Jack. URL will be published in our HTML file, and when we run the Python code in through our PowerShell, and it will update in our web API via a web API to our website. So I'm going to show you the our HTML code already is published here. So to use our Nano API server EC2 instance, so we are going to use the command of creating the HTML file, and we need to use this command to deploy the our HTML code, and so this HTML code must have the API URL. So it's showing here. So it's already I pasted the code from my HTML code into our EC2 server. So
are you sharing any screen, Jeniken?
Yeah. Can you see?
Oh, I don't think so. Yeah, now it should be fine.
Oh, sorry. Yeah, I forgot to share the screen share.
That's why you weren't unable to watch.
Yeah. So this EC2 instance have this HTML file. So this HTML file has this API URL. So which is built in our AWS server. It contains the Lambda messages and API gateway. If we used to enter the sample data through the PowerShell Python API, so it will appear on our web interface. We already added some sample data when we do the demo. So I'm going to show you how to use this HTML file in our EC2 instance. So we need to use the sudo command to create a public folder worldwide web HTML index.html. So I'm going to show you the command, the HTML file, which we pasted in our EC2 AWS instance. So we already pasted the API URL here. So when we run the command through the PowerShell, and it will post a sample data of our UI interface. That's all, guys.
Yeah, all good.
So we finally got an output of the web interface after configuring the API gateway and DynamoDB and Lambda message routes and everything. So it's run on our public instance IP. So it's already running. So the as I mentioned earlier, so if we can able to in future, we can use the HTTPS, which means we can edit the rule for to able to access from anywhere and any protocol to access our website. But this one is not secure because we are using the HTTP protocol only. So if we in future we can add the rule to run as the HTTPS, which means the secure protocol 443. So this all we already discussed in our this meeting. So if we have anything to discuss, we can discuss. Any idea, guys?
Yeah, okay.
Amen. Any idea?
Sorry, what was that?
Mainly we covered most of the things in this group discussion. So anything else to concern
I think this was very detailed. I'm happy.
Okay. So everybody happy? Then let's finish our meeting. Thank you guys. Thanks
Yeah.
for your time.
Thanks,
Thanks, everyone.
Have a good night.
Yeah.
See you. Bye.
Have a good night.
Good night.
So-